Hey guys, for you, this is AP Calculus AB. We're talking about the section 1.3 on the fundamental theorem of calculus. There are some extra little details that we need to make sure that you have a chance to observe. So in this problem, we have a function, checkpoint 1.17. We have a problem that's defined as the antiderivative, capital F of x equals the integral from 1 to x to the third. Notice it's a little different than the last question here, but it's of cosine t dt. So if we're going to find the antiderivative, no, we did, there it is. We want to find the derivative of the antiderivative. We've got a little bit of a chain rule that we need to work on. So check this out. First of all, this function right here, this x to the third, if we think of it like a u of x, which equals x to the third, then what we remember from Calc 1 is that we have to also acknowledge that there must be considered a u prime of x, which would be 3x squared. Everything's all in reference to dx, so I don't need to think about like some sort of extra piece here at the end. One other way we could probably write it is like du over dx, meaning these are notationally referring to the same thing even though they're slightly different. Now, here's our problem. We need to go back and look at the derivative of the antiderivative. So that would be like a way to cancel out the function that's here. Like the antiderivative of cosine would be sine. And then if you take its derivative, you'd come back to cosine. So if we write this as fundamental theorem of calculus part 2, the antiderivative, we would write sine of t plus c, right? The plus c part. We would evaluate it from 1 to x to the third. The issue there is we're not really looking to do that. There's a problem there that we got to be careful and acknowledge here. But coming backwards, taking the derivative of this thing, all's well and good if we're doing things with respect to t. But we're not. We want f prime of x, which means we want the derivative of the antiderivative with respect to x. So in order for us to solve that with this problem, it's going to be this integrand, cosine of t, d of cosine of t, with respect to, I'm going to put that up here, I'm going to put a u. It's like we're changing our vision, and then we also have to chain rule it up and use the du dx. That's because we can't just straight swap this x for t and call it done. When we're talking about derivatives, we still have to follow the properties of derivatives. So that means chain rule when the chain rule is appropriate. The derivative of the integral from 1 to u. I missed that part right there, so I'm going to kind of slip that in there, pencil mark it. Now that means the derivative of the antiderivative, we get cosine of u times u prime. Let's put in the things that we know. We know that u is supposed to be x to the third. So cosine of x to the third. And then u prime is supposed to be 3x squared. Maybe move the 3 to the front and put the x squared along the way. There you have it. The chain rule in action in finding the derivative of the antiderivative. Thanks for watching the video.